Okay, in this problem we want to we have a rectangle inside of a triangle. We want to find the rectangle of maximum area. So the goal here is to maximize area. So our objective function is going to be area of the rectangle of maximum area. So the area of the rectangle is x times y. That's a pretty straightforward objective function. But it's got to be inscribed in a right triangle with legs. A in this case is equal to 2 and B is equal to 8. Okay, so what we're going to do to get A, the objective function, in terms of one variable, either all x's or all y's, is we're going to use similar triangles here. So I'm going to use the big triangle as one of my triangles because I know its side lengths are 8 and 2. And then either this little triangle or this little triangle for the other one. So I think I'll go with this one, this small triangle right here. And we'll set a proportion between that and this bigger triangle right here. Okay, there's a number of ways you could set up the proportion. It doesn't matter which way you do it. I'm going to go with x over 8 equals this whole length, which would be 2 over this whole, or no, x over this length. That's not 8. X over this side length is actually the total side is 8 minus that distance is 8 minus y. So that's the length from there to there is 8 minus y. So the ratio of x over that equals 2 over the full side length, which would be 8. And you can solve for either variable in terms of the other. I'm going to multiply both sides by 8 and 8 minus y, in other words, cross multiplying to get 8x equals 2 times 8 minus y. And I'm going to solve for x because that just looks easier from here. So dividing both sides by 8, we'll have 2 over 8, which simplifies to 1/4. So we have 8 minus y over 4. And then we can plug that into the area function right there to get that the area is equal to x times y, where x is 8 minus y over 4 times y is just y. Now before I differentiate, I'm going to go ahead and expand and fully simplify this out. So I'm going to pull this 4 out front as 1/4 and distribute the y over that. So this 4 is the 1/4 there. And then that's going to be times 8y minus y squared. So there's my area function. That's a good simplified version of it. So for that is what you can go ahead and differentiate. The 4th would hang out front times the derivative of this would be 8 minus 2y. So you would look for a critical value where that equals 0. Multiply both sides by 4 and that goes away, so we get 8 minus 2y equals 0. Or where does 8 equal 2y, which looks like at y equals 4, is the critical value of the function. Okay, the variable that I went with here is y. So let's see, I'm going to see if I can find the endpoints for y. It looks like the smallest that y could realistically be is 0. That's what makes sense for the problem. The largest y could be would be this leg length is 2. Let's see, we want to find the rectangle of maximum area. So the area, if y is 0, that's supposed to say a of 0. The area of the rectangle, if y is 0, would be x times 0. Or the area of the rectangle if x was 2. No, if y is 2. Well, if y is 2, then x has got to be, I think I said that wrong. If y is 2, that doesn't make sense. If I was reading this wrong, let's think about this again. So the smallest y could be is 0, which is if this x is down here. The largest y could be is not 2. The largest y could be is actually this leg length, which is 8, which is what it would be if x was 0. So as if this pink leg came all the way up. So mess that up. If y is 8, then x is 0, so the area would be 0. So we could check to make sure that the area is a max by using either the second derivative test or by finding the area when y is 4. I'm going to go ahead and check just with the second derivative test. So the second derivative would be a fourth times 0, and then the derivative of negative 2y is negative. So the second derivative of a is negative, which tells us that a is concave up, and so therefore it's going to have a minimum by the second derivative test, which is, no, said that backwards. A is concave down if the second derivative is negative, so a has a max, which is what we want. And then you would go solve for x right here when y is 4.